Chapter 15. Work, Force and Energy. You are asked to move a chair. In how many ways can you move it? Think of other things you move, open and close every day. What do you do to make each of them to move or to open or to close? We see many things around us. Some of these things do not move, while some others move. We see carts, bicycles, cars, buses, trucks, etc. moving on the road. Have you ever thought how things move? A cart is pulled by an animal. A bicycle moves when we push the pedal. A train is pulled by an engine. To move something, you either push or pull it. A push or pull is called a force. We pull or push the door in order to open it. The force applied by the pull or push moves the door. Nothing moves on its own. Everything needs a push or pull to make it move. Let us see, what do we do while pulling or pushing a thing? Apply a force on the thing being pulled or pushed. When a force is applied, the object moves. Put your bag on the table or the floor. Now pull it towards yourself. What have you observed? The bag moves on pulling. Now let your friend join you in pulling the bag. What difference do you observe? Now the bag moves faster. Now we have learned that we can make an object move by applying force on it. By applying more force, we can move the object faster. What else can a force do besides moving an object? It can stop a moving object. It can change the direction of a moving object. It can slow down a moving object. When we want to stop a moving object, we have to apply force in the opposite direction. When we apply force on some soft objects, their shapes change. We use force for taking our paste or medicinal cream from tubes, rolling chapatis, crushing boiled potatoes, etc. Force can slow down or stop a moving object or change its direction of motion. When force is applied on some soft objects, their shapes change. Friction. Have you ever pushed a heavy box lying on the floor? If yes, then you must have experienced that it is difficult to push a heavy box. Why? When we push the box, the floor opposes its movement. To push a heavy object, we have to use more force. Otherwise, it will not move at all. In fact, the floor applies a force on the object in a direction opposite to its motion. This force is called friction. Do different surfaces have the same friction? Let us find out. When you push your toy car on a carpet, it slows down and stops after some time. Friction occurs because of the rubbing of the toy car against the rough surface of the carpet. Push the toy car against the rough surface of the carpet. Now push the toy car on a smooth floor. Does it go further? The force of friction is less on a smooth surface. In comparison to a smooth surface, the friction due to a rough surface is more. Friction helps you in your several activities. Writing with a chalk on a rough blackboard is easier than writing on a smooth blackboard. You may also have experienced that it is difficult to walk on a smooth surface. You can slip on a smooth surface as it causes less friction. Friction is the force generated between a moving body and the surface on which it moves. The frictional force ultimately stops a moving body. Rough grooves are made on the surface of tires to prevent them from slipping on the road. The sole of the shoes and slippers are made rough so that it may not slip. In some situations, friction is disadvantageous too. Friction hinders the motion of vehicles. In order to reduce friction, we put grease or oil in sewing machines, fodder cutting machines, etc. Force of gravity. When a football is kicked towards the sky, it moves up. After some time, it comes down to the ground. A ripe mango or any other fruits falls down on the ground. When it breaks from a tree, it does not go up. This happens because the earth pulls the mango towards itself. The pull force caused by the earth is called gravitational force. All objects are affected by the gravitational force of the earth. Gravitational force was first discovered by Sir Isaac Newton. Fact so, objects with mass are attracted to each other. Magnetic force. A magnet pulls certain things towards it. Which things does it pull towards itself? We put some iron nails, pins, pieces of paper, and pieces of chalk on the floor or the table. Now bring a magnet near these objects. We can see that the objects made of iron have stuck to the magnet. The magnet attracts objects made of iron. The force applied by a magnet on an object is called magnetic force. Work. We apply force when we lift a thing from a table. In this process, the thing changes its place, that is from the table to our hands. Similarly, when we pull a bicycle, we apply force and the bicycle changes its place. We apply force on objects when we try to pull, push, or move them. When an object changes its position from one place to another on applying force, work is said to be done. Work done equals sine force x distance moved. You cannot push or pull a wall. While pulling or pushing, the well does not move. Its position remains as it is because the position of the wall does not change. So no work is done. Energy. Look at the pictures given below. Different activities. Works have been shown here. To perform any activity, we need energy. Energy is the ability to do work. We need energy to walk, to run, to play, to drive a car, to push a table, to pull a rickshaw, etc. A machine needs energy to work. A car needs energy to move. Energy is also required to change matter. Cooking food requires energy. Everything requires energy to do work. We obtain energy from food that we eat. Vehicles need energy to move. They obtain this energy from petrol or diesel. Petrol and diesel are obtained from petroleum. Forms of energy. Muscular energy. Man uses the energy of his muscles to do many kinds of works like lifting heavy loads, moving things from one place to another, etc. He also uses animals like horses, camels, etc. to help him in his work. Men and animals get energy from the food they eat. Heat energy. We get heat energy by burning fuel such as wood, coal, gas or petrol. Heat energy is used to cook food and to run cars and steam engines. Solar energy. It is the energy of the sun. It has heat and light energy. We can see things during the day due to the light energy of the sun. The solar radiation is also used to operate many things like solar cookers. Plants use the light energy of the sun to make food for all living beings. When we eat this food, we get energy to do work. So we are dependent on the sun for our energy needs. Fact zone. Benjamin Thompson 1753 to 1814, known in Europe as Count Unford, was the first person to show that heat is a form of energy. Electrical energy. We use electricity to do certain types of work. There are many appliances in which electric current is passed to do a work. It is used for heating, lighting and operating machines, etc. Electrical fans, motors, grinding machines, tube wells, etc. Work due to electrical energy. We press our clothes with an electric iron and warm our houses with a heater. Chemical energy. It is stored in batteries and obtained from chemicals. It is used in torches, radios, and music systems. Water energy. Energy from flowing water can be used to run water mills. Falling water is used to produce hydroelectricity. Wind energy. Moving air is called wind, and it has wind energy. This energy is used to run windmills. Windmills are used to pump water, produce electricity, and run wheat grinding machines. Minerals, coal, petroleum and natural gas resources are limited in the nature. They are decreasing slowly. If not used wisely, they will get exhausted after a certain period of time. Therefore, we should use these resources carefully and judiciously. We can conserve them by avoiding their wastage and by using their alternatives. Fact Zone. The Bakra Nangal Dam, situated across the river Satluj in Himachal Pradesh, is the largest dam in Bihar and the highest gravity dam in the world. Concept map, workforce and energy. Force, friction, force of gravity, magnetic force, work, energy. Force of energy,